For 80 years, every Polish ship entering the Baltic Sea had to ask Russia for permission. Not anymore. In just 1.3 kilometers, Poland spent $450 million to cut through solid sand, build a lock that defies the sea, and draw a new map of European power. But why risk diplomatic fury, environmental warnings, and engineering nightmares for a canal most sailors won't even notice? The answer reveals how infrastructure quietly redraws borders and why this tiny waterway is already changing the balance of power in Northern Europe. To understand why Poland dug through its own coastline, you have to rewind to 1945. The end of World War II didn't just redraw maps, it redrew sovereignty. The Baltic coast, once a patchwork of German, Polish, and Prussian territories, was carved up by victorious powers. Kaliningrad, formerly Königsberg, became Soviet territory, a Russian exclave, a military fortress, and sitting just south of it, the Baltic Strait. This narrow waterway was the only navigable passage between the Vistula Lagoon and the open Baltic. And for decades, it operated under Russian maritime authority. Polish vessels couldn't just sail out. They had to transit through a strait governed by a foreign power, subject to inspections, delays, and political leverage. In peacetime, it was a logistical headache. In times of tension, it was a choke point. Poland's northern ports, Elbląg, Frombork, Krynica Morska, were economically stranded. The lagoon could support fishing, tourism, and light maritime trade. But without independent sea access, it couldn't scale, couldn't integrate into European supply chains, couldn't project sovereignty. For 80 years, Poland accepted it as a post-war reality, until it didn't. The turning point wasn't a single event, it was a pattern. 2014, Crimea, the Baltic Sea suddenly felt less like a trade corridor and more like a front line. 2022, full-scale invasion in Ukraine. Energy blockades, maritime sanctions, Russian naval exercises within sight of Polish waters. The Baltic Strait wasn't just a choke point anymore. It was a vulnerability. Polish strategists ran the numbers. In a crisis, Russian authorities could slow transit, impose inspections, restrict military or dual-use vessels, even close the strait temporarily under security protocols. Poland's maritime access wasn't just dependent on Russia, it was conditional. And in modern geopolitics, conditional access is no access at all. So in 2018, the Polish government approved what would become one of the most controversial infrastructure projects in modern Europe. Not a highway, not a pipeline, a canal, through a fragile sand spit, into one of the most ecologically sensitive coastal zones in the Baltic, with a price tag of $450 million. And a clear message. Poland will no longer sail through another nation's permission slip. But building it would mean fighting geology, weather, diplomacy, and time. And the first battle wouldn't be political. It would be geological. What happens when you try to cut through a coastline that's actively trying to heal itself? The Vistula Spit isn't rock. It's a 70-kilometer wall of loose sand, shifting tides, and brutal Baltic waves. Geologically, it's a barrier spit, a narrow landform created by centuries of longshore drift, wave action, and sediment deposition. It's not static. It breathes. It shifts. It rebuilds itself after storms. And Poland wanted to cut straight through it. To an engineer, a sand spit is a nightmare. Unlike bedrock, sand has no shear strength. Remove material, and gravity does the rest. Add water, and capillary action weakens it further. Expose it to waves, and it erodes exponentially. This isn't digging through dirt, it's digging through a living, moving system. And the Baltic doesn't care about political borders. Before a single excavator touched the ground, scientists spent 2 years modeling wave patterns, sediment transport, and groundwater flow. They ran hydrodynamic simulations, tested soil samples, mapped tidal influences. The conclusion was clear. If you remove sand without reinforcing it, the Baltic swallows your trench in hours. So the first question wasn't how to dig. It was how to keep what you dig from collapsing back into the sea. The answer came in 3 layers: 1. Steel. 2. Vibration. 3. Time. But before stabilization could begin, Poland had to answer a different question, one that would ignite debates across Europe. Was this canal really about trade, or was it about sovereignty? Let's look at what happens when engineering meets ecology. To open the canal route through the sand barrier, contractors deployed dozens of large hydraulic excavators operating continuously along the site. Layers of sand, mud, and sediment were excavated and transported by heavy dump trucks to nearby coastal staging areas. But here's the catch. This wasn't just digging, it was triage. Every cubic meter removed changed the local hydrology. Water pressure shifted. Pore spaces collapsed. Without immediate reinforcement, the trench walls would slump. So engineers didn't wait. They moved in parallel. As excavators dug, pile drivers followed. Hundreds of steel piles were driven deep into the sandy ground along both sides of the excavation route. Not just for support, for confinement. Think of them as temporary ribs holding a collapsing chest open. Each pile locked adjacent sand layers, reduced lateral water flow, and created a stable excavation corridor. Next came deep vibrocompaction. A specialized probe vibrates the soil at high frequency. The sand particles rearrange, voids collapse. Density increases. It's not magic, it's physics. And it's the difference between a trench that holds and a trench that slides. The excavation and ground stabilization phase alone lasted for many months. Millions of tons of sediment moved, but none of it was wasted. Instead of being discarded, this material was stockpiled, tested, and repurposed. It would become the foundation for what came next. The breakwater, the canal's shield against the sea. But a breakwater isn't built on land, it's built in water. And water doesn't follow blueprints. Breakwaters aren't walls, they're shock absorbers. Their job isn't to stop waves, it's to bleed their energy. And in the Baltic, waves don't just crash, they resonate, they reflect, they compound. Construction began with the formation of the breakwater core using sand and fill materials recycled from the earlier canal excavation phase. Thousands of tons of material were continuously transported to the sea entrance to create the initial foundation. Once the core was shaped, workers drove large numbers of steel sheet piles deep into the coastal sandy ground. These piles defined the alignment, locked the geometry, acted as a temporary skeleton. Next, concrete and reinforcement structures were poured along the steel line. But the real innovation came after. Massive concrete blocks were installed on the outer face, not solid, hollow, engineered with intentional gaps and openings in the middle. Why hollow? Because solid blocks reflect energy. Hollow blocks absorb it. Water enters the voids. Turbulence increases internally. Pressure equalizes. The wave's force is broken, not bounced. It's hydraulic judo. Use the sea's momentum against itself. And the excess sand? It didn't vanish. It became an artificial island near the canal entrance. Initially just a circular sand formation, gradually expanded with soil, rock, and engineered substrates. Within 3 years, it became a protected nesting habitat for coastal birds. Engineering that heals. That's the standard. Workers dropped double-layer steel walls into the seabed, then pumped out millions of gallons. Suddenly, they weren't building underwater. They were building in a man-made desert. The lock is 270 meters long, 4 gates, each weighing approximately 160 tons, operated by hydraulic systems capable of completely sealing the chamber. Raise the water, lower the water. Smooth transitions, no turbulence. Inside, groundwater regulation pipes and automatic valves maintain stable flow. The entire process is managed through a network of sensors and an electronic control center. And when a ship approaches, 2 swing bridges rotate 90 degrees in minutes. Land traffic pauses for 90 seconds. Then life resumes. Given the narrow geography of the Spit, this was the only viable solution. Optimize space, minimize disruption, synchronize land and sea, maritime infrastructure, automated mechanics, synchronized transport. from chaotic construction site to a machine that runs itself. But engineering doesn't exist in a vacuum. It exists in politics. And politics doesn't care about blueprints. Russia called it a threat. NATO called it autonomy. Environmental groups called it irreversible. Who was right? Russia called it a military threat. NATO called it strategic autonomy. Environmental groups warned of lagoon ecosystem shifts. Poland's response? It's civilian, it's ours. The approval process was prolonged. Reviews commissioned. Hearings held. Reports filed. But Poland held its line. This wasn't about tonnage. It was about dependency. In 2022, when the first phase opened, Poland didn't just gain a route. They removed a choke point. Behind the steel and concrete were thousands of workers, pile drivers, crane operators, surveyors, environmental monitors, men and women who spent winters on the spit, summers in the mud, navigating Baltic weather, logistical delays, and political uncertainty. They weren't just building a canal, they were building a statement. And when that first Polish vessel passed through the newly opened lock, it wasn't just water moving. It was sovereignty, but what did it cost the ecosystem? But sovereignty isn't free. $450 million. Years of diplomatic friction. Permanent changes to coastal currents. The Vistula Lagoon is a brackish ecosystem, sensitive, dynamic. Home to migratory birds, fish spawning grounds, and delicate salinity balances. Cutting through the spit changed water exchange rates, altered sediment deposition, shifted local currents. Mitigation wasn't an afterthought. It was engineered in. Artificial reefs, controlled sediment release, real-time water quality monitoring. The breakwaters' hollow blocks didn't just reduce wave pressure. They created microhabitats. The artificial island didn't just use excess sand. It became a protected nesting zone. Was it a masterstroke of national strategy or a geopolitical gamble with ecological trade-offs? The answer isn't binary. Infrastructure always extracts something. The question is what you give back. Poland chose to build with monitoring, not just momentum. To adapt, not just impose. And in a warming climate, that's the only model that lasts. But how does a 1.3-kilometer canal compare to the giants? Compared to Suez or Panama, the Vistula Spit Canal is microscopic. But scale isn't the metric here. Symbolism is. In 1869, the Suez Canal opened, 190 kilometers, a shortcut between empires. In 1956, Egypt nationalized it, not just for tolls, for sovereignty. The message was clear. Strategic infrastructure belongs to the nation that controls its shores. Panama took decades. Mountains moved, jungles cleared, thousands lost. But in 1999, Panama reclaimed full control, not just of water, of destiny. Poland proved you don't need a 190-kilometer trench to change the map. Sometimes 1.3 kilometers of steel and will is enough. Because canals aren't just about moving ships. They're about moving power. So where does this leave the Baltic today? Today, the Vistula Spit Canal isn't just a waterway. It's a strategic node. Polish patrol vessels transit freely. Logistics chains bypass Russian-controlled straits. Regional ports see renewed investment. The canal doesn't replace major trade routes. It secures national ones. And in an era of hybrid warfare, energy blockades, and maritime coercion, redundancy is resilience. The next phase isn't about length. It's about integration. Smart ports, automated traffic control, renewable energy integration. The canal was phase 1. The network is phase 2. And Poland isn't stopping at sovereignty. They're building autonomy. Behind the layers of concrete and steel lies a broader story. About a small nation that refused to accept conditional access, that chose to dig, stabilize, build, and adapt. Not for glory, for independence. So what do you think? Was the Vistula Spit Canal a necessary shield against geopolitical leverage, or a costly overreach with irreversible ecological trade-offs? Drop your take below. I read every comment, and I'll reply to the top 10 most thoughtful arguments in 24 hours.